So let's see one by one in a detailed manner. Depolarization phase. Let's quickly recollect one by one in a detailed manner. Depolarization phase. So it's a negative membrane potential becomes less negative, reaches to zero. Then the positive. Okay. So stimulus membrane of the axon to depolarize to minus. So what happens is that when there is a stimulus, that stimulus produces results in the inflow. That stimulus can be ion gated channel. So when there is a stimulus, there is opening of a small opening of Na plus ions into the cell, and that Na plus ions reduces the potential from minus 70 to minus 55 millivolts. Once the minus 70 to minus 55 millivolts comes, then it immediately produces the action potential, because the threshold voltage of sodium ions to produce an action potential is minus 55 millivolts. That's what we saw in the previous video. Okay, so you see, when the membrane potential of the axon reaches the threshold, the Na plus channel activation gets open. So this is an activation gate. Something that's in the middle of the channel is called an activation gate, and this one is called an inactivation gate. As the Na plus moves through these channels into the neuron, a buildup of the positive charges forms inside the cell. So they get depolarized and they become positive. It goes to minus 30 millivolt. Okay, that's what in the this state inactivation gate is open, but the activation gate is closed. Okay, but in the threshold both of them are open. So this is the threshold and both of them are open. Okay, let's say what is in the resting state. So resting state, activation gate is closed, inactivation gate is open. So this is the activation gate, this is the inactivation gate. Okay, so when the stimulus comes, okay, when the when the stimulus comes and this stimulus is impinged on one of the Na plus ion gate channels, it produces minus 55 millivolt. Then immediately this activation gate channel opens, and there is an influx of sodium ions into the cell. This causes cell to be more positive. Okay, so channels are opening, and so during the repolarization phase, now in the repolarization phase, the threshold potential for potassium channels to open is minus 30 plus 30 millivolt. So once plus 30 millivolt opens, what happens is potassium channels open. Okay, potassium, the repolarization phase, potassium channels open, and there is outflux of potassium channels outside the cell, causing the cell to become more negative. And what happens to the sodium channels? Sodium channel, the activation gates remain, so activation gates remain open, but the inactivation gates remain closed. Okay, so this is something that you need to write in your exam more clearly during the explaining the action potential. Okay, so now the cell becomes more negative and reaches the equilibrium potential of potassium, that is minus 90 millivolt, but the resting membranation potential minus 70 millivolt, right? So a potassium pump acts in the between to bring the cell from hyperpolarized state, okay, to the resting membrane state. Okay, so as I told you, the refractory period, absolute refractory period, is the time when any strong stimulus is applied, there is no response in the action, there won't be an action potential. But in the relative refractory period, there is a stimulus applied, there will be an action potential. So what is the absolute refractory period? The absolute refractory period is the relative refractory period is the hyperpolarization phase. Absolute refraction period is the repolarization phase. Okay, this is one more recollection of what we have read. This is minus 70 millivolt for the nerve cell, and 90 millivolt minus for skeletal cardiac muscles. Their duration in milliseconds. Okay, thank you.